Today we'll be talking about operators in Python. So what are operators? In Python, operators are used to perform operations on variables and values. That is, performing operations with some operational signs. So we have different types of operators. We have the arithmetic operators, we have the assignment operators, we have the comparison operators, we have the logical operators, we have the identity operators, we have the membership operators. So we're actually going to talk about each of those operators and then make a few examples on these operators in our VS Code. So we have the Python arithmetic operators. So arithmetic operators are used with numeric values to perform common mathematical operators which we are already familiar to, like making our addition operations, subtraction operations, our multiplication operations, division operations, modulus operations, exponentiation operations, and floor division. So I'm actually going to delve to our VS Code and make a few examples using this Python arithmetic operators. I'm actually going to make an example with a floor division. So floor division is actually whereby there's a division that happens between two numbers, and then after the division the output gives out, it produces an output that equates to the nearest whole integer. We're already familiar with integers, right? Integers are whole numbers. So let me say I have this example here, which is x equal to 5 and then y equal to 2. And then I say print x floor. I'm actually performing a floor division, so I'm actually going to put y here. So I'm putting the variables inside the print command. So I'm saying okay, 5 modulus 2. So this is actually going to give me an output and then return an output that equates to the nearest whole integer. So on a normal division, if I make a normal division using my normal division like this, then I'll come here, save this guy, come to my terminal, Python, I'm going to have 2.5. If you actually check my terminal here, I'm having 2.5. Dividing 5 over 2, I'm getting 2.5. So when I now apply my floor division, my arithmetic floor division here, and save it, and then come to my terminal and run the code, I'm getting 2. So what floor does for us is that it rounds it up to the nearest what integer. That is what floor does for us. So we also have another type of arithmetic. Like I said, I'm actually going to be making a few examples on arithmetic operators. We can actually try some on our own to see how it works. So I have my modulus. So in modulus now, what modulus does is that, in a normal division, it returns a quotient and also a remainder. So what a modulus does for us is that instead of returning that quotient, modulus returns the remainder. So let me say I have 10, I have x equal to 10 and then y equal to 3. Then I say print 10 modulus. This is a sign for modulus 3. So I'm going to save this and come to my terminal and run this guy. So I'm having 1. So if you go through a normal division processes, you see that while dividing 3 over 3, while dividing 10 by 3, you're actually going to get 3 and then a remainder of 1. So this is what modulus does for us. Modulus returns the remainder for us instead of what the quotient. So we will be talking about other types of operators. So we've talked about the arithmetic operators. So we have the Python assignment operators. So we have the equal. So what does the assignment operator does for us? The arithmetic operators does an operation of a normal mathematical operations. Here, assignments are used to assign values to a variable. So you have x as a variable, and then you now say equal to, use an equal to assignment. So you're now assigning a value to a variable, which is x equal to 5. So 5 is now the assignment which you have given to x using the operator equal to. So I'm actually going to go through some examples of, we have the plus equal to, we have the minus equal to, we have the exponentiation equal to, we have the division equal to, the modulus equal to, the floor equal to, the exponent equal to, the and equal to, the or equal to, the exponent equal to 2. We have the we call it the bitwise, that is this part. We have the bitwise left shift assignment. So this I'm actually going to talk about this bitwise. So it's used in binary operations. So you actually make use of bitwise shift, left shift. This is called left shift. This is the right shift of assignment operators. So we'll actually delve in and make some examples of this assignment operators in our VS Code. So I'm actually going to comment this. I'll comment this and come here. So I will say x. I'm now assigning x. This is our variable x. So if I make equal to 5, I've used the assignment operator equal to assign, say print print x. So if I save my code and come here to the terminal and run it, so I'm going to be having x. I've assigned a value 5 to x. So I have other examples. I'm actually going to say s equal to 10. Then x exponent equal to 3. Exponent equal to 3, print x. So if you come here, you know what our exponent does for us. Our exponent it multiplies a number, just like raise. We call it normally, we said 10 raised to power 3. So when you multiply 10 into 3 forms, it gives us what? 1000. To make the output clear, I'm actually going to comment this and then still come to the terminal and run it. So we still have our 1000 here. So this is what exponent assignment does for us. So we also have, like I said, we also have the bit. I'm going to comment this one. We also have the bitwise left shift assignment. So we're actually going to do an example with this. So we have x equal to 2, and then we have x, use the less than sign, double less than sign, equal to 2. So that in binary, if you actually know your binary variable, in binary 2 is equal to 0010. So when you say x bitwise left shift, so it pushes the binary number of 2 in 2 positions, in a left 2 positions. So we're actually going to now get our output. When I now say print x, so when it pushes it into like in a left like shift it in a leftwise position, like in two, let me say in two places, 1 2 by your left, it's actually going to give us a value 1000. Like let me say we are having, this is what we are having here. In binary we'll have 2 as 0 1, sorry, 0010. So when we push this guy to a position in our left hand, shift it in two places leftwise, so we're going to be having 1000. We're going to be having 1000, and 1000 in binary is equal to what? Is equal to 8. So when we now say print x, we're going to be getting our output as 8. So this is what assignment, that is what bitwise left shift assignment does for us. So we're getting an output of 8. If you look at my terminal here, we're getting an output of 8. So if we actually know our binary very well, this is what we use for our binary operations in Python. So we're actually going to be delving to other types of operators. We have the comparison operators. So the comparison operators are used to compare two values. So we have the equal to, we have the not equal to, and we have the greater than. So we'll be making some examples in our comparison operators. So let us delve to our VS Code to see how this works. So I'm actually going to comment this guy here. So I'll come here and say assign A equal to 10 and B equal to 15. I'll then say print A not equal to 15. So print A not equal to 15. So when I save my code, I come here. So if you actually check here very well, if you check my my terminal here, it's telling me true, because if you check the condition, A is equal to 10 and B is equal to 15, and we'll say print using the, we are using the comparison operator not equal to. So actually in an actual sense, with the values I assigned to A and B, A is not actually equal to B, because A, 10 and 15 are two different numbers. So I'm getting a true. So if I still change this, can put the variable, let me put the variable because I'm working with variables, so it makes more sense, though it's still the same thing. I can still pass in my numbers, so it's still true. So if I come here now, say run my operator on my terminal, so I'm having a false. So print, I'm using the equal to sign, equal to, for you to use a comparison for the equal to, use a double equal to sign. So print A equal to B, which is false. So A is not equal to B. So if I actually say here, still put in my greater than, so A is greater than, it's actually going to throw me a false, because normally we know that A is not greater than B. So this is what comparison operators does for us. So we have the other types of comparison operators. We can still try this. We can still try this at our own pace. So we now have the Python logical operators. We have the logical operators. Say logical operators are used to combine conditional statements. So if we've actually done JavaScript, we actually have come across these types of logical operators whereby we use and, or not. So we use and to return conditional statements that when you make a condition, it returns a true boolean value. when the two statements are actually true. But for OR, it returns a true Boolean value when one of the statements is true. So what NOT does for us, it returns the reverse of, maybe if a condition is true, it returns the reverse that it is false. If it's false, it returns the reverse that it is true. So I'm actually going to delve to my VS Code and run an example or a few examples. So I'm going to comment this guy I have here. So I have some numbers. I'm actually going to use my value A, my variable A equal to 5. I'm going to assign a 5 value. B equal to 10. C equal to 15. You can assign any value you want. So I want to run a conditional, a condition with and or. So I will then say num equal to, that is number equal to A. So A less than B and B less than C. Then I'll say print num. So if you actually check the condition I've passed, you see that each of the conditions are actually true. So this is what AND does for us. So when I go to my terminal and run my code, it's showing a true Boolean value. If I actually change this guy here to a greater than using an AND logical operator, let me save it. Then come to my VS Code and run it. It's showing a false because AND accepts the two values should be true. So if one value throws a false and the other one throws a true, it's going to be a false. But when we come to OR, we make use of OR, it's going to be true because in this case, for OR, one has to be true. So if I run this, sorry, I didn't save it. If I run this guy here, it's giving me a true. So if I actually change this guy here and still use an or logical operator, so here I'm having both conditions as true, right? So when I now run this guy here at the terminal, I'm getting what? Sorry, save it please. So I come to my terminal and then run it. It's giving me what? So it's actually giving me a true, right? Because one of the conditions is true, but though both conditions are true. So even though the other one is not true, but it accepts that at least one must be true for an OR logical operator to be successful. So